Lesson 7.1, the tangent ratio. So in the introduction to trig, we were introduced to the tangent ratio, the sine ratio, and the cosine ratio. In this lesson, we're going to focus just on the tangent ratio. We're going to review some of the topics that we discussed in the introduction and expand on them just a little bit. So the first trigonometric ratio that we will work with is the tangent ratio. Tangent ratio relates the two smaller sides of the right angled triangle, or the legs. So as a review, a right angled triangle has the hypotenuse, which we already knew, but we learned the two other sides, or the legs, can be called the opposite and the adjacent. So what we name those sides depends on the angle that we're dealing with. So it's important to first identify the important angle. So in this triangle, if we're looking at angle A, the opposite side is the side directly across from it, and the adjacent side is the angle that the side that helps make up that angle, the one next to it. Okay, so the tangent ratio helps us find a relationship between those two sides, the opposite and the adjacent. So we're able to define the tangent ratio as the length of the opposite side over the length of the adjacent side. Or more simply put, the tangent of angle A is opposite over adjacent. So let's look at an example. Determine the tangent ratio for angles A and B, or find the tan of A and the tan of B in the triangle shown. So we have a triangle here. We're going to find the ratio for angle A and the ratio for angle B. So those are two separate problems. We'll do them one at a time. So the ratio for angle A, remember that the tan of A is opposite over adjacent. So if we're dealing with angle A, that's our important angle here. If we identify our opposite and adjacent sides, we should be able to write this ratio. So if A is our important angle, the opposite side would be BC, which is 5, and the adjacent side would be CA, which is 3. So the tangent of A, or the tangent ratio for angle A, would be 5 over 3. So I want you to take a second and see if you can find the tangent ratio for angle B. So use angle B as your important angle, identify your sides, and write the ratio. Okay, so angle B, or the tan of angle B, would be opposite over adjacent, but this time my opposite side is the side that's directly across from angle B, which would be CA, or the 3 unit length side. And the adjacent side would be side BC, which is 5 units long. So the tangent of angle B is 3 over 5. So depending on which angle we're focusing on, the tangent ratio changes just a little bit. And it's important that we have our sides correctly labeled so that we have the proper ratio. So once you determine the tangent of an angle, you can use a scientific calculator to determine the measure of that angle in degrees. So once I determine that tan of A equals some ratio, I can go and solve for a value of that angle A. So we're not calculating the tangent, we're using the inverse tangent function. So what that means is we're pressing the shift tan or the second function tan button. So whenever we're looking for an angle, we're going to use that shift tan or second function tan button. So let's sample. Determine the measure of angle A and angle B by writing the tan ratios and solving for the angle. So we start by writing the ratio like we did in the last example, but then we go a step further and solve it. So let's start with finding angle A. So remember, the tan of angle A is opposite over adjacent. So if we're looking at angle A, my opposite side would be 8, and my adjacent side would be 5. So my ratio would be 8 over 5. I can convert that fraction into a decimal, and it makes it a little bit easier to work with. So the tangent of A is 1.6. So now we have to actually solve for A itself. And to do that, like I said in the last slide, whenever we're looking for a particular angle, we use that second function or shift button in our calculator. So you're going to put it in 1.6 and then second function tan or shift tan. And we should get that angle A is 58 degrees. So take a second, follow the same process, and see if you can find the measure for angle B. So write your ratio, turn it into a decimal, and then use that shift or second button to help find the angle. Okay, so tan of B is opposite over adjacent, but this time my opposite side for angle B is 5, and my adjacent side is 8. So my ratio would be 5 over 8. So I can convert that into a decimal to make it easier to work with, and I get that the tan of angle B is 0.625. If I use that second or shift button in my calculator, I get that angle B is 32 degrees. So the neat thing is now we've found angle A and we've found angle B, we can actually go back and check to make sure we're correct. So you can verify these answers easily. So we know that all of the angles of a triangle have to add up to 180 degrees. So angles A, B, and C have to add up to 180 degrees. So we found angle A, we found angle B, but we also know that C, because it's a right triangle, is 90 degrees. So if we test it, we can see that the 90 degrees, which is angle C, plus the 58 degrees for angle A, plus the 32 degrees for angle B equals 180 degrees. So because our three angles add up to 180, it looks like our answer is pretty good. Okay, so let's look at one more example. So this example didn't come with a diagram, it's a word problem. A ladder rests against the side of a building with its base 3.2 feet from the wall. The top of the ladder is 7.8 feet up from the ground. What angle does the ladder make with the ground? So whenever we're dealing with trig and we're not given a diagram, we should sketch a diagram. It's really difficult to actually write our ratio without seeing the image. So the important thing to remember is that we're dealing with right triangles and only right triangles. So if you sketch a diagram and you don't have a right triangle, then you probably haven't sketched it properly and you should go back and try again. So we do it step by step. So first I usually draw the situation. So it's a ladder leaning up against a building, and then I label it. So the base of the ladder is 3.2 feet from the wall, and the ladder is 7.8 feet from the top of the ground. So my diagram would look something like this. So you can see I have my building there, and I have my ladder up against it. So the base of my ladder, which is the bottom of my ladder, is 3.2 feet from the building, so that's the measurement along the bottom. The top of my ladder is 7.8 feet from the ground, so that's the height of my building. And I'm looking for what angle does the ladder make with the ground. So when I'm talking about the angle the ladder makes with the ground, I need to find out where the ladder and the ground meet, which is down where I've marked that A. So that's the angle I'm looking for. So now that I've kind of created a right triangle between my building and the ground and the ladder, and I've labeled two sides and I know what angle I'm looking for, I can solve this the same way I did the last problem. So take a second and see if you can solve for angle A. Okay, let's have a look. So we know that tan is opposite over adjacent, and in this case my opposite side is 7.8 and my adjacent side is 3.2. If I convert that to a decimal, I'm using 4 decimal places here. With trig, I like to use 4 decimal places when I'm working through the questions, and then at the very end, my final answer, I can round a little bit. So 7.8 divided by 3.2 should give me 2.4375, and then I use that second function or shift button to help determine that angle A is 68 degrees, so round it a tiny bit. So the ladder makes a 68-degree angle with the ground. So when you're given a word problem and you're not given a diagram, make sure you sketch a diagram and label it. Your diagram should be made of a right triangle in some form. Otherwise, it really doesn't make sense to be dealing with trig. So that is the end of lesson 7.1 on the tangent ratio. So there are some book problems that you can work on, and there's also a worksheet that you can work on as well.